Alrighty.
Today, we're going to do a Trig lecture for worksheet 10.5 and worksheet 10.6. The objective is given an angle in standard position in the Cartesian coordinate plane, that's just the XY plane. The student will state the quadrant in which the terminal side lies. So we're going to be given an angle. It's going to be in standard position, which is what I'll discuss here in just a second, in the Cartesian coordinate plane. And once we're given that angle, you'll have to determine which quadrant the terminal side lies in. Okay, and I'll tell you how to do that starting right here. Standard position of an angle. We have two sides of an angle. We have what we call the initial side. The initial side is always the positive x-axis. We have the Cartesian coordinate plane, that's the x and y axes. The positive x-axis is the initial side of our angle, and we are going to rotate the other side and form an angle, and it's going to stop somewhere. Wherever it stops, we're going to call that the terminal side. If we rotate in this direction, we call that positive rotation. If we rotate in this direction, if we were to start here and rotate it in this direction and stopped here, we would say that's a negative rotation. You can rotate in a positive direction, going counterclockwise, or in a negative direction, going clockwise. In either event, wherever you stop is called the terminal side, and the initial side is always the positive x-axis. Okay, so what we're going to be doing, let's see if I can get rid of this, is defining what quadrant means. When you have the y-axis and the x-axis, it takes our plane and chops it into four quadrants. This quadrant right here, this section of the plane that these chop it into is called quadrant 1. This section of the plane right here is called quadrant 2. Quadrant 3 is down here in this region. And this region is quadrant 4. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So if I asked you, in what quadrant does this terminal side lie, you would tell me it lies in quadrant 1. Okay? It could be a positive rotation that stops there, or it could be a negative rotation that stops there. The question is, which quadrant does the terminal side lie in? Okay. Here's one where the terminal side stops in quadrant 2. Quadrant 1, 2, 3, 4. Here's the initial side, always the positive x-axis. This rotation could be positive and stop here. Positive rotation goes like this. Or it could be a negative rotation and stop in the exact same place. In either event, the terminal side stops in quadrant 2, and that's what you're going to be asked to identify. In which quadrant does the terminal side lie, regardless of whether it rotates positively or negatively. Okay, so let's take a look at this one. Here's the initial side again, always the x-axis, xy axes chop our plane into four quadrants, so to speak. If we rotated in a positive direction from the initial side and rotated our axis like this, or our terminal side like this, and stopped positive rotation, that's called the angle of rotation, we would be stopping in quadrant 3. So the terminal side stops in quadrant 3, regardless of whether it's a positive rotation or a negative rotation. We start here and rotate in a negative direction. If we stop right here, that is a quadrant 3 angle, terminal side. Okay? And we have an example here of fourth quadrant. Again, our initial side is always the positive x-axis. And if our terminal side is in this quadrant, we call that quadrant 4, quadrant 1, 2, 3, 4. And we could rotate positively or negatively and wind up here. If we started here and then rotated like in a positive direction and stopped here, that would be a terminal side in quadrant 4. As it would if we started here at the initial side and rotated in a negative direction. Negative direction. This would still be a quadrant 4 terminal side. Okay? So that's what we're going to be dealing with. We're going to be given some angles. We're going to remember that the positive x-axis is always the initial side, and then from there we're going to rotate so many degrees as is indicated by whatever problem the problem tells us to rotate. And we're going to stop and then determine what quadrant we're in. That's what we're going to be trying to do here. So let's take a look at this. State the quadrant in which the terminal side of each angle lies. Well, what I'm going to do here, I'll show you how I would do it. I would draw some axes, just rough sketch, doesn't have to be real neat. And it's X and Y. This would be quadrant 1, quadrant 2, quadrant 3, quadrant 4. And it's telling me an angle of negative 435 degrees. Well, I know that my initial side is the positive x-axis. And the other side, the terminal side, it starts right here. That's a 0 degree angle. You can think of it as just one side overlapping the other one. That's a 0 degree angle. And then we're going to rotate in a negative direction for 435 degrees. So if I rotate in this direction and stop right here, that's a rotation of 90 degrees. But I don't want to stop at 90. I want to keep going until I get to 435. So I'm going to add 90s. Every time I hit an axis, I've gone another 90 degrees. Here's a 90 degree negative rotation. Here's another 90 degree negative rotation. So now I'm up to 180. 90 more gives me 270. 90 more gives me 360 degrees. So I've rotated my terminal side 360 degrees. If I go another 90, that'll take me to 450. I'm at negative 435 is what I'm looking for. So I'm going to go to about here, roughly, and sketch. This doesn't have to be very accurate. What I'm looking for is the quadrant. I know I'll be in quadrant 4 at negative 435 because from here to here is 360. And if I go all the way to the next axis, that would be 360 plus 90 would be 450. So 435 has got to be somewhere between 360 and 450. And we rotated in a negative direction. This is negative rotation. So my answer is, because my instructions say, state the quadrant in which the terminal side of each angle lies. The answer is quadrant 4. That's what we're looking for. And that's how we found it. Okay? Let's take a look at this one. We're going to do the same thing, just set up a little XY Cartesian coordinate plane, named after René Descartes, was the guy that came up with this, or he's given credit for it anyway. French mathematician and philosopher. 555 degrees is positive, so I'm going to rotate in a positive direction. There's my origin right there. So here's my initial side. That's the initial side, and now I'm going to rotate in a positive direction, and I'm going to count by 90s again. Each time I go to an axis, I've rotated another 90 degrees, and I'm going to keep going until I get in the range of 550 degrees. Here we go. If I rotate to here, and that's my terminal side, that's 90. If I rotate another 90, that's 180. So here we go. There's 90, plus 90 is 180, 270, 360, 450, 540. Now, I've got to go 15 more degrees to get to 555. That's not a perfect sketch, but it is positive, and it's in the neighborhood of 555 degrees, and I know now that this angle, if I haven't made a mistake, is a quadrant 3 angle. It will stop in quadrant 3. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. We won't have any of them stop on the worksheet. None of them will stop on the actual axis itself. They could. We call those quadrantal angles. That's just the name for them, quadrantal angles. But for today, we're just going to be stopping in various quadrants. Let's take a look at this one. A couple more, just doing the same thing, just trying to identify in what quadrant the angle lies, the terminal side. This is the y-axis, the x-axis, there's my origin. Here's my initial side, and then I'm going to rotate positive 168 degrees. Well, there's positive 90 rotation. There's positive 180. 168 is in quadrant 2. It's going to be what, 22 degrees from a full 180 degree rotation. So something like this. It doesn't have to be perfect, but that's approximately or roughly 168 degrees, and that puts me in quadrant 2. Here's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So my answer is quadrant 2. 168 degrees, positive 168 degrees is a rotation that lands me in quadrant 2 if we're in standard form. Standard form is the initial side is the positive x-axis, and the terminal side stops whenever you achieve whatever rotation you're looking for. Remember, positive rotation is counterclockwise, negative rotation is clockwise. So here we go. Last example, I think. Yep. So we're going to do the same thing, just looking for the quadrant in which the angle lies. Y-axis, x-axis, origin, Cartesian coordinate plane. You know, you have coordinates on there, 1, 2, 3, 4, 5, so forth and so on. We're just rotating. There's my initial side, positive x-axis. I'm going to rotate in a negative direction, so I'm going to be rotating like this. Now I'm going to just keep counting until I get in the range of 280 degrees and then figure out what quadrant I'm in. Remember, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So here we go. Rotating in a negative direction, there's 90 degrees, negative 180, negative 270. If I go 10 more, that's rough, that's probably a little bigger than 10, but it puts me in quadrant 1, I can see that. This may not be exactly negative 280 degree rotation, but I do know that if I rotate to here, that's 270, so 10 more will put me in quadrant 1. And that's what we're looking for. Again, state the quadrant in which the terminal side of each angle lies. Remember that the initial side is always the positive x-axis, and then you either rotate positively or negatively depending on the angle that you're given. If you rotate in a negative direction, you'll rotate clockwise, starting from the initial side, positive x-axis. If you rotate in a positive direction, you'll rotate like this. Okay? I hope that makes sense.